Hello everyone, greetings from India. My name is Han. Right, today I will be going with my very first tutorial regarding the software named FreeCAD. It is an open source software. Well, before starting, I would like to give some credits. The very first, my guide, my teacher, and my inspiration, Dr. H.S. Rai, because of whom uh, I came to know about the software and I'm doing this tutorial. And the second, the developers of the software, FreeCAD, like Yorick and others, they're really doing a very good job making a free software, an open source software. So today we'll be making a structure, a very basic structure, such a structure with 4 columns, 4 beams, 4 footings, and we'll be applying loads, analyzing it, seeing its simulation. We'll be going through a basic walkthrough of it. So let's start with that. The very first thing with that is to make a new file. We'll go with the architectural design. So you see there are many methods with which you can build your building. You can build your structure. The very first we can select a workbench, a plane. Let's have a x axis. You can see a grid here. It's the top view, elevation, the front view, the top view, the side view, another side view, bottom view, the side view. So we're starting with the XY axis. Before starting that, you can check your grid size from the references. Go to the draft workbench, grid and snapping, and set your grid spacing to 1000 mm for better grid spacing. Click apply. Now you see there are many methods with which you can build your structure. Like you see, you can directly have your structure here. I can show you an example. Set the structure here. You can select its length, width. Like you want to build a footing, its length should be like 1000, 2000 to, you can say, that's a 500, and its position, you can directly go here also on the screen, but I would prefer you to use the coordinates. Let the x-axis be 0, global x coordinate 0, global y coordinate 0, z 0, and then enter the point. So what you see here, you get your footing here. You can also change its sides later. Like for a structure, you can see here the parameters height, length, and width. Select the role of it, like you want it to be the foundation. Like suppose, let's change its height. Let's its height to be around 300. So you can see the change is implemented here. I'll go to the top view. Now you want 4 footings here. Very simple thing. You can simply set structure, the footing here. You can rename it like you want it to be F1. So you say F1 footing. Now simply go to the draft section. You can check from the utilities. Here also you can view. We'll prefer to go for the draft. From here, select the array option. So you got the array of the footings. Now you want to set some parameters like the number of the footings. In Z we want it to be 0, and the interval in the x-axis, let it be like 5 meters, and interval in the y, let it be like 5 meters. So you see, in a few clicks and entering some parameters, we've got our 4 footings. It's very quick. It will be going very slow here so that you can easily see every click and every parameter, how it's entered and how you have to use it. Next, we would like to build some columns here, like 4 columns. Again, simply clicking on the structure part. We've got a structure here. Now, selecting the structure here, the mistake earlier we did, like we selected the array and put a structure here. And what will happen there? We lost our structures. Now what you simply have to do is click on the empty space, click structure. Now again you got the parameters here. We want the length of the column to be around, let us say 500, width also 500, and we want its height to be around to 5 meters, and its position should be at 500 in X and 500 in Y, and to the point. So you see the basic error you're getting here. The only way you will learn is by your errors. You see, if you see this was the origin, we have selected X and Y around 500. So what we can do, modification here, go to the structure, go to displacement, and then position. Put the Y to the 0. So you see how quickly you can adjust your data and your structures. Now you want to have some more columns. Again, simply with the same scenario, click the structure and let's rename it. Let it be C1. Select the C1. Also check its role, it's already column. Again, from the draft, select the array, enter the intervals. So you see, you've got your 4 columns. Very nicely, very clean, and very quickly. And one more thing I would like to tell you in between, like this is not an ordinary CAD software. The 3D model that you're getting is not just 3D models or frames or like just faces. They're actually the BIM, you can say the BIM parameters or the BIM libraries. Better word should be BIM libraries. Like this is a column, so it exactly means a column. It has its properties and several other parameters we will see later. So now we will go for the beam building. Like the top view, click on the empty space, click for the structure again, So we want its length to be around 5000, width to be around, let us say 500, height should be again 500. So next part should be about its position. Let's start with it from 500x. Y should be 0. And we would like to place it. Remember that. Let's have it around 5 meters above. We will see if any changes are needed. So see, you can see your beam here, and to pan like this, what you need to do is hold your Alt key of the keyboard and just roll over the mouse. It's very simple and user friendly. You can see your beam here, and let's rename it. First we have roll beam and say it B1. Enter. Now let's build a perpendicular beam in a similar manner. Now the length should be changed to the width. The length to be 500. We'll be building a perpendicular beam. Width should be 5000. Height should be 500. So you see. Now you see we are getting a midpoint here. So what we need to do is to adjust our coordinate by thinking and placing in the midpoint. So the x will remain 500 only. For the y will go to 2500 because total distance is 5000. So we just enter the point. The z will be 5000. Enter the point, and you see how cleanly you got it. But we are facing a minor problem here. You can see the beam is above it. So what we need to do is you can simply first check the earlier beam, its properties, and then correlate with it. The width, length, and height parameters are okay. So the problem lies in the position. So what we will do is go to the placement, go for the position. We need to adjust the Z parameter. It's not okay actually. So what we'll basically do is simply minus 250 from here. You'll slowly by slowly learn the adjustment by simply looking the visual 3D object. So if you minus 250 from 500, we'll get something like 4750. So you see how by adjusting the parameters you are able to adjust it. Let's name it B2. Hit enter. Again with the array command. Now we want the structure, the beam, to be next direction. X2, the X interval should be around 5000. So we have got our requirement. Actually we forgot the array of the B1, the column, draft, array, y interval 1000. Yeah, I think X also here. So you see the error wave like this. So Finally, we have got our structure here ready. One thing more you will like to do is you save the structure. So let us save it on desktop for the time being. Name it my first model, and the file format is .fcstd. Save. Now, to analyze the structure in FreeCAD, what basically you need to do is you need to combine the structures. Now, there are arrays of different structures. What basically you'll do is simply go to the part workbench, select all the arrays, and now simply union of the surface shapes. Now you see you have got a fusion here. All your structure things are saved in the fusion. I got a combined model. Now go to the FEM. Our last part is here. FEM workbench. Select the fusion model. Select the create a new mechanical analysis. You get a mesh text parameter here. For time being, select the 1000. The size of mesh. You set the fineness. Let it is moderate. Select OK. And you can see how quickly we have got the mesh here. Well, it depends on the complexity of the model. If you have a bigger model, the mesh will be more complex and it will take more time. Basically, FreeCAD is in the developing mode. It's developing very rapidly, but it's doing quite a good job. Now our mesh is ready. Click on the mechanical LC object and go to the material definition. For the time being, let us say you can select concrete generic, and you can see the properties here. You can also change them, or we have the predefined properties here. Select OK, and you can see we can get the things here. Now we need our mold, the footings to be fixed here. Select this FEM constraint for the fixed material entity. Just simply, the very simple thing is here, just select the faces, and you can see they are fixed here. The footing is fixed. Simply select the other face, the other folding, simply this one and this. You can see the face here set here. Now simply click on the OK button. Now we have done with the constraints of the fix. Now let's go for the loads applied. We have clicked on the pressure constraints. Now for time being, let's it to be 20 ampere, or you can say 10 ampere. Add references. Simply select the top surface of the beams. We have not added slab here for time being because the slab load also is transferred to the beams, and from the beams it goes down to the columns. Second reference, the beam face. Third reference, and last 4 reference, and select OK. So now we have done almost with all our work. We have got the mesh, we have got the loads, we have got the fixed footings. And now the last part is go to the CalculiX. It's also actually a plugin here. It's a very good software, you should say. And here we can see a dial to solve the calculation. You can start by here, or if you want quickly, it will write the input file and run the CalculiX. But we'll go to the dialog box. Here you can write the input file. We can check the static functions of the frequency. We'll go for the frequency also, but let's see the static functions here and analysis. Write input file. The file is completed and run the CalculiX. So you see time taken by it. Results are loaded and close here. Go to results and go to this box. So we would like to see the absolute displacement. So you can see here how good visual we can see, and where the stress is more, the red part of the beams signifies and symbolize the maximum stress zones where the stress is most. And now for seeing the displacement simulation, simply click on the show button here dialog and simply drag this bar. You can see the simulation, how accurate and how good it is. You can change it like this and see the simulation, how it goes. You can change it more, like changing its slider maximum and the factor. You can change it to the 100. So you can see the behavior of the building. Where there is more red zone, you can provide more steel there. Like you can see displacement in the X direction. Similarly Y. Similarly Z displacement. You can see it's minus 22 mm. Maximum is 8 mm. Average minimum this. Won't misses stress. Basically, we require the absolute displacement to analyze structure. So here we had around 2 centimeters average, and the maximum is 13 centimeters. Well, it's quite huge. We need to focus on our footings here, the column and the beam size. Well, this was a small demonstration. You can do your own experiments on this. You can build your own complex structures. You can go for more tutorials on this. Well, this was a starting tutorial. Hope you guys like it. Well, this I have learned from my own experience and own documentation. There are actually very small material available for the FreeCAD. One more thing we're discussing, like the frequency here. Select the frequency, input file, and calculates. It's taking some time. So results are loaded. Close. So see how much results we have got. So you see, this is something another more interesting thing. You can see how it behaves laterally. I think there are many leading softwares in the market, proprietary software in the market. I use them already, but I've never seen an interface and the ease with which the FreeCAD shows us the simulations. No other software shows in such a good manner. The mode 3 results. You can see the rotation also here. Something more interesting, how it's bending. You see, it's very fascinating things. These are very fascinating things. I, as a new user for the FreeCAD, I found it very interesting. Mode 4 results. I see it has given me 10 results. See, another twisting thing here. You can do as many things as you want, depending on your usage and requirement. Now you see how it behaves outwards, and the absolute displacement here. So you can see the structure in every manner. That's really interesting. Mode 6. You see how it behaves here. So going through all these phases, we can design a very safe and a very perfect structure. Seeing its behavior to the loads, how it behaves, how it simulates before actually building. And one thing more I would like to add side by side, that this software FreeCAD is very BIM friendly. It follows the ISO code, and the file it generates, the IFC file, is very good. We will see in some other tutorials as we're building that also. See, you see, it's really interesting. We can have some more complex structures and see its simulations. You can also upload your structures, your files That will be more interesting and more welcome. Well, that was all for today. I hope you guys like that the tutorials. Your reviews, your comments will be welcome. Any suggestions, any corrections that can be made. I'm also in the learning mode only. I'm learning day by day new things. Well, thank you. Let's have end to the today's tutorial. See you soon, guys. Thank you so much. This one is Bichohan from India.